Hello everybody, this is 3.4. I'm going to continue on with our line stuff. This one's got a little bit more homework in it. It's got 18 points, so I'll try to do maybe one of it every type, and then I think that should be good. So we're going to be writing equations and graphing equations and things like that. So let's take a look at what we got here. We have a graphical representation of a line, right? Okay, and we're supposed to write the equation. Well, let's take a look at what we have for lines. All right, so back to our y equals mx plus b. Okay, keep seeing the same thing over and over and over, but that's good. M is the slope, and the b is where it crosses the y-axis, so that's the y-intercept. And whenever you write an equation, that's all you need. You just need the m and the b. That's the only two things that we need. The x and the y always stay in there. So for instance, we might have a line that looks like this, 2x plus 4. Okay, we know the slope is 4, we know it's crossing at, the slope is 2, excuse me, and it's crossing at 4. Okay, so this is our goal, is to get it to look like this. So this is all we need is m and b. So let's start with m. Okay, so now we've already seen that if we wanted to, we could do a formula. We could do the points. We could say that, this is 4, 4, and this is, what is this, 0, 1. Plug it in and do it that way. But I'm also going to show you a different way. It's a little faster, using this. Okay? So what I'm going to do is I'm going to go from one point to another point. I'm going to go from, let's just say randomly, this point to that point. Now I can see that my line is tipped upward, so I'm going uphill. So it's going to be a positive number. And so if I have to get from this point to this point, what am I changing as far as my rise goes? I start here and I'm going to 1, 2, I have to go up 3, right? So there's my rise. I'm changing 3. And then from this point here, how far do I have to go over? I have to go over 1, 2, 3, 4. So there's my slope, 3/4. Okay, so it's the rise, the change in the y from here to here to the run. Okay, so I have to go 1, 2, 3, up 3, over 4. So there's my slope. So that's a good start. So far what I have is 3/4 x. Okay, now I want to find my y-intercept. Remember, my y-intercept is where it crosses the y-axis. So it's this point right here. This point is 0, 1. So my y-intercept is a positive 1. There's my line. Okay? So it's telling us to use fractions. So we will use the fraction part of this. So we've got to get the x in there plus 1. Okay? So that's what we're going to do when we've been given a line graphically. We're going to look at some points. It doesn't matter which two you choose. Okay, don't pick, for instance, this point because it's not on a grid point. But otherwise, yeah, any 2 points that you can really make sure that you know what they are, and we can calculate out with the formula or just visually, rise over run, and then we have to see where it's crossing. Okay? Bing, bada, boom. So we're going to do the same thing here. This should be a negative, right? Let's just do the slope real quick. Okay, so we have rise over run. Come on, why does my pen do that? I don't know why it does that. Okay, so I'm going to go randomly from this point to this point. I could have gone from this point to this point too, it doesn't matter. So what do I have to do? I have to go up 1, 2, 3. Okay, so up is on the y-axis is positive. Now from this point I have to go to the left 1 to get to this point. Left on the x-axis is negative. Okay? So this is a slope of -3. Now let's go the other way. Just want to show you something here. Okay, so let's go from this point to this point. Well, I do my rise first, but I'm going negatively because I'm going down. 1, 2, 3, so it's a -3. And then from this point to get over, I have to go over +1 on the x-axis. Still is -3. So it doesn't matter if you go from, one point or another, you're still going to get the same slope. My y-intercept here is 2. That's where it's crossing, right here. So my equation would be y is equal to -3x plus 2. Okay? All right. Okay. So now let's take a look at if we would have information given to us like this rather than graphically. We're still working within this formula, all right? Still only need the slope and the y-intercept, always. This time we've been given it and it's super easy. I mean, we know that the slope is -4, so I just slap that in where I see the m, and the y-intercept is a +2. Okay, that's just too easy. Okay. This slope-intercept form, that's this. This is slope-intercept form. Okay? There's another one that's point-slope form, which I don't like as well. But let me see if I can't drop this down just a bit. Okay, so where am I here? Oh, there I am. Okay, I gotta drop this down so I can see the whole thing. I gotta go more. Sorry about that, guys. I gotta get that tool palette. Okay, so now what we're gonna do is we're gonna graph. So we're going the other way. We've been given the equation, we want to graph it. It says we're supposed to use the slope and the y-intercept to graph it. Well, that's pretty easy. So first of all, let's pick our line tool. Okay, and the first thing that I want to do is I want to go to my y-intercept. It's a +4, so that's going to be 0, 4. There's 1 point on my graph. Okay, now what I'm going to do is I'm going to use my slope. Okay, my slope is -3. Let's just go down here for a second. M is -3, which is the same as -3/1. Okay, so here's my rise over run. So it's telling me where to go. It's telling me to go down from that point, go down 3 to the right 1. Okay? So up in here, I'm going to go from this point, I'm going to go down 3, 1, 2, 3, and to the right 1. And there's my line. I've got a negative slope, so that means it's running downhill, which is good. It's going through the point 0, 4. Okay? Pretty easy when you've been given an equation like this to graph it. Now, are they all this easy? Probably not. See, now here we don't know what the slope and the y-intercept is because it's not in the slope-intercept form, so we might have to do a little monkeying around first, right? So if you've been given something like this, you need to solve for y. Okay, we've already done that. So we're going to move our x over. We want it in the y equals mx plus b form. So I've got 4y is equal to minus x plus 12. Remember, I always want to put my x term first. My x was negative, my 12 was positive, so I want to retain those signs. All right. Then I want to divide through by 4. Divide through by 4 and clean it up. Okay? We're going to divide both terms on the top by 4 because that's what that's telling me to do, right? Negative x divided by 4, 12 divided by 4. There really is a 1 here. So I'm going to pull that fraction out front. Okay, 12 divided by 4 is 3. So now look what I can see from here. This is my y-intercept. Okay, so I know where it's crossing, and I know what to do. From this point, I'm going to go down 1 to the right 4. This is negative and this is positive. Okay? Select a tool palette, yes. I know. Alright, so what was my -1/4 x plus 3? Like I said, I have oops, dang it. Okay, so if you do that, then we have to clear it out. Okay, so here is 0, 3. It's my y-intercept. I had a negative 1/4, so I'm going to go down 1 and to the right 4. Okay? Does that look good? I've got a negative slope, so it's going downhill. It's crossing at 3, right? That's what this is telling me. It's looking good to me. Now here's another thing that you can do. Okay? You can take your y equals and throw it into your calculator. I've got to get rid of all this stuff here, sorry. And we can check points on here. So we've got a negative 1 divided by 4, x plus 3. This is kind of a nice check to do before you test, like before you hit submit during a test. But you can see that, yeah, my line is looking the same as this, and then we can check certain points to make sure that they're on there. Okay, let's check to make sure that 3, 0 is on there. 0, 3, excuse me. 0, 3 is on there, good. And then this one looks like it's at 4, 2, doesn't it? Yeah, so there it is. So we can do some double checking that way too. Okay? Alright, so now what we're going to do is we're going to go back to more of an algebraic kind of a thinking here. We've been given the slope and just a random point, okay? So again, we have to use this. Okay, slope, y-intercept, that's all I need. I've been given the slope. Slope is 8/9, piece of cake. 8/9 x plus b. I have not been given b. B has to be where x is 0. It's the y-intercept. I have some random point, 6, negative 3. This is not the y-intercept. I cannot put in b because I have no idea what it is. So what I have to do is I have to find b. Okay, and I'm going to find b because I know that this equation here is a line, and every x, y ordered pair that sits on that line is right here. Okay, it's telling me it goes through this point right here. So this xy pair is on my line. So therefore I can put it in. If I have 6, negative 3, and that's an xy combination that does sit on the line, I'm going to put my y of negative 3 here. I'm going to put my x of 6 here, and I can solve for b. Okay, so I've got negative 3 is equal to 8/9 times 6 plus b. Because this pair, this ordered pair, is on the line, this is its slope, I can find where it crosses the y-axis. Okay? So 8/9 of 6, if you don't like doing fractions by hand, times 6. Math, enter, enter. We've got 16/3. Okay, then we would subtract the 16/3 across both sides. 16/3 minus 16/3 is gone, so all we have left is the b on this side. And I'm going to take negative 3 minus 16/3. Get my decimal version and turn it over to a fraction, negative 25/3. Okay? So we are going to go back up in here and put that in. We always want our y, we always want our x, and then we have our y-intercept. So here's my line right here. Okay, 8/9 x minus 25/3. Okay, so let's see what else we got in here. Drag this down. Graph the line passing through the given point and having the given slope. Oh, all right, that's pretty easy. So we're going to grab our line tool. I'm going to first of all go to this point because that's one of the points that's on the line. That one's super easy. 1, -1, click. Now I've got to determine where my second point is. I see that I have a negative slope, so my line is going to be this way rather than this way. Okay, so from this point, it's telling me now this negative can go either with the rise or the run, but not both. Okay, so I'm just going to randomly put it up with the 5. All right, so what it's telling me is to go from that point, go down 5 to the right 3. This one's going to be the negative one, this one will be the positive one. Or if I put this down with the 3, then I could have gone up 5 to the left 3. So it's just which side of the line you're graphing, it doesn't matter. So like I said, I'm going to choose to put it with the 5. So from this point, I'm going to go down 5. Okay, so that's going to be right here, correct? Down 5 to the right 3. 2, 3. I think that's right. So there's my line. Okay? Now, the slope-intercept form of the equation of the line, we're back to where we were before. Okay, this stuff down in here. I don't really see where my y-intercept is. It's somewhere in between 0 and 1, but I don't know what it is. It's not on a grid point, so I'm going to have to use my algebra to figure this one out. So if I have y equals mx plus b, and I know my m, and here's my x and here's my y, okay, so I've got -1 is equal to -5/3 times 1 plus b. What I'm doing is I'm trying to solve for b again. This is just a -5/3. So I would add 5/3 across both sides. So b is equal to, you're doing some fractions by hand later in the semester. Math, enter, enter. So we've got 2/3. Does that look about right? Yeah, it's about 2/3 of the way up. So looking at the line, if this thing was like 15 halves, which is 7.5, that would be wrong because it's got to be a number between 0 and 1. We can visually see that. So yeah, we're down into a number between 0 and 1, so it's probably correct. So my equation is this. Okay, I always want to keep my x and my y in there. All I need is my slope and my y-intercept. That's it. All right? Yeah. Finding an equation of a line, then graph it. Well, this one's really pretty simple. Okay, we're going back into our y equals mx plus b form. Here we're told that m is 0. And my y-intercept is, remember, it's going to be 0 and then some y value, which I've been given here, 0. So I've got -2. That's gone. 0 times x is 0, so I've just got this. So all my y values are going to be -2. They're going to be stuck there. So this is actually a horizontal line. I'm just going to pick any value that has a y value of, oops, I can't go back. Okay, I can't do that. I can't stay on that and point at the same time, but you can see that my y value is -2, and I'm just going to choose any other one. Okay. So it just has to be a horizontal line that runs through all my y values for all my points are -2. Alright, here's a different type. It says that I want to graph a line going through this point. Okay, so that's where we'll start, is 5, 5. Okay, so it goes through that point, and the information that I have here is an undefined slope. Well, an undefined slope means what? It means it's a vertical line. Okay, so I just pick any other point that has an x coordinate of 5, and I'm done. Remember that? Remember, anything with a 0 slope is horizontal, anything with a undefined slope is vertical. Anything running uphill is positive, and anything running downhill is negative. All right. Now we have 2 points, and neither one of them are of any particular significance. They're not the x or y intercepts, they're just points. So we have some sort of a line, okay? We've got 1, 5, 1, 2, 3, 4, 5. Let's just see what we got going on here. There's 1, and then 3, 6, 1, 2, 3, 6 here. So we've got some sort of a line coming in like this. So I would expect it to be a positive slope. I don't know where it crosses here, so let's find out. Again, all we need is the slope and the y-intercept. I have neither. But look what I have. I have 2 points. I can always find the slope between any 2 points. Because I don't have a graph, I think what I'll do is I'll just use the formula. So it's y2 minus y1 over x2 minus, come on, x2 minus x1. I randomly said this is 0.1 and 0.2, just so I keep things straight. So I've got 6 minus 5, right? And I've got 3 minus 1. 6 minus 5 is 1. 3 minus 1 is 2. So there's my slope, 1/2 x plus b. Now in order to find b, I need just a random point. Well, I got 2 of them. Doesn't matter which one I choose. So I'm just going to randomly choose the first one, just because it looks easier. Okay, so I'm going to choose 1, 5. Which is just some random xy that does sit on the line, right? This is a point that is on my line. I'm going to put in my 5 here. That's what my y is, right here. And I'm going to put my 1 in for my x. And now I can find where it crosses here. Okay? 1/2 times 1 is 1/2. Subtract off, whoops, 1/2 on either side. So b is 4.5. We don't want that way because it's going to ask us for fractional stuff. So 4.5, let's do this. That's the same. So we multiply 4 times 2 is 8 plus 1 is 9/2. So I'm going to go back to this one right here and I'm going to rewrite my entire equation out. I've got 1/2 x plus 9/2. Okay, so let's look to see if this is even reasonable. I have a positive slope and it's pretty flat. Okay, it's not going up a whole lot. So I've got kind of like up 1 over 2. Yeah, that looks about right. And it's positive, it's going uphill. And 4.5, does that look like it's about right? 1, 2, 3, 4.5. Yeah, you know, my line, I'm just sketching here really quick, but yeah, it looks like it could fall right in between there. So this looks very reasonable to me. So we have 1/2 x. Nope. I gotta get out of there. X plus 9/2. Looks good. So you can find the equation of a line really by given, you know, we've been given all this different information in here. You know, sometimes we have graphs, sometimes we have slope and the y-intercept, sometimes we have slope and just a random point, and sometimes we just have 2 random points. So there's a lot that we can figure out just by very little information in through here. You can do the same thing. Okay? You're just going to be working with fractions. No big deal. Okay. Let's take a look at this one. Down at the bottom here, I'm going to have to get a clean screen pretty quick. Alright, so we have a line. Okay? And we want to write an equation of a line that's parallel to this line, but runs through this point. So this point is not on this line. It's going to be on my new line. Let's say this is old line, new line. So what do we know about parallel lines? Well, we know that they have the same slope. So if I knew the slope of the old line, then I could figure out the slope of the new line because it's exactly the same. So the first thing that I'm going to do is I'm going to determine what my slope of my old line is. And in order to do that, I have to get it into my y equals mx plus b form so I can see it. Okay, so I have to take my old equation and solve for y. All right, I can do that. I've got negative 9y is negative 2x plus 7. Divide through by negative 9, all of this. Okay, and then I'm going to clean it up. I'm going to split it. So I've got y is equal to a negative 2 and a negative 9 is a positive 2/9. Okay, and then I've got negative 7/9. I don't really care what this is, okay, but I'm going to put it in anyway. What can I deduce from that? Well, I can see my slope is 2/9 on my old line. If these are parallel, my new line will also have a slope of 2/9. Okay, so that's my old stuff. Now we're going to do a new line that's parallel to the old one. So far what we have is the slope. How can I find b? Well, I have to find some random point. Have I been given a random point? Yes. It says that it contains this point. So I go back into the negative 3, that's my y value, 2/9 of x, which is 6, plus b. Boy, these b and that 6 look an awful lot alike, don't they? Maybe I'll make this a capital B just until I'm done with it. Now I can solve for b. Okay, so I'm going to take 2/9 of 6 times 6, and what do I get? Math, enter, enter, 4/3. So I have a, boy, I'm running out of room here. When I'm done with this one, I'll get a new screen. I've got negative 3 is equal to 4/3 plus b. Then I'm going to subtract the 4/3 across. Okay, so b is equal to whatever this is. So I've got a negative 3 minus 4/3. And I'll turn that into negative 13/3. Okay, that goes right here. I've got my slope and my y-intercept. That's all I ever need. So my equation is 2/9 x minus 13/3. There's my equation. It's parallel to this because this one had the slope of 2/9, and it's going through a different y-intercept. It's just shifted up or down. Let's see if this is correct. Please be correct, right? Is that what you guys do when you're checking your stuff? Oh, you cross your fingers, please, 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 please. I do the same. Should probably drag that down just a little bit so you can see. I sure hope that I'm in the, yeah, I am in the window. All right. So let's get a new screen, shall we? Select all to delete, and we'll go back to our pen, and I'm going to go back to top. Minimize my ribbon. All right. This one's very similar, except this time we want to go perpendicular to the given line. So I'll get you started on this one. All right. I'll at least get you the slope. And from there you should be good, because then it's nothing new. So, old line. I need the slope. I've got 8x plus y is equal to 9. So here I have to solve for y. Boy, this one's going to be easy. Okay, this is gone, so I have y is equal to minus 8x plus 9. What is my slope? My slope is a negative 8. So remember, on perpendicular lines we have the negative reciprocal slope. Okay, so on my new line, first of all, I want to turn this into a fraction so I can flip something, otherwise I don't have anything to flip, right? So this one was negative, so this one will be positive. So this is going to be a positive. Then I just invert. So if it's just a whole number, I want to put the 1 underneath it. And so I know that my new slope is an eighth, positive. Okay, so there's your start, 1/8 x plus b. Now I need b, I need some random point. I've been given this random point. Slap it in there, calculate out b, there's your equation. Okay? Same thing here. Okay, we've got a perpendicular line, we got to figure out what our old slope is, negative reciprocal slope, blah, blah, blah. Okay, so maybe we should do some word problems together. We've only got 18 points, so we've only got 4 here. So I'll do a few of these, and then we'll be done. Okay, it costs $17 flat fee to rent a lawnmower, plus $5 a day starting with the first day. Let X represent the number of days so that Y represents the charge. Okay. So if we put in our generic, because it's got to come in that form, and it's telling us, now again I'm going to label what I have. Okay, it says let X represent the number of days rented. Okay, so this is your days. So Y represents the charge. Well, I can do that. Okay, I know that I have $5 a day, so if that's my days, however many days I have, I'm charged $5. And then my y-intercept, or my flat fee, I have to add on $17 just to rent it. Okay, and this is your days. So here's my equation. That looks good. We've got 5x plus 17. So this will be our generic equation that tells us how to figure out if we rent for 1 day, 2 days, 3 days, 4 days, that kind of stuff. So the ordered pair associated with the value of the x value of 0 is, well, what that's asking me for is I want to find out the corresponding y value here. Okay? The corresponding y value here when x is 0 is the y-intercept, isn't it? Isn't when x is 0, then when I'm looking for the y-intercept? And isn't the y-intercept right here? So isn't that this? Or another way to look at it is if I put a 0 in right here, this wipes out. So y is equal to 17. Either way, we've got 0, 17 for our point. Okay. What else do we have? A rental car is $50 plus 80 cents per mile. Okay. X is the number of miles and Y is the total charge. Well, then we're going to put this in. This is our variable, right? This is what varies because we don't know how many miles we are going to drive. And then this is our constant. This is our y-intercept. Okay, so we're going to do 0.8x plus 50. Okay, so if I drove it 0 miles, I'd still have to pay $50. If I drive it 1 mile, then I'm going to have to pay $50.8. Okay, that's what that's telling me. Let me drop this. Oops, that was the wrong one. Where am I? Right here. Choose the correct answer below. Sometimes you have to go back up in here and read the question before you can pick. Sometimes they don't rewrite it. It says find and interpret the ordered pair associated with the equation for x is equal to 5. Okay, so if x is equal to 5 and 5 is the number, or x is the number of miles driven, then the ordered pair associated means that the charge for driving the car for 5 miles is so many dollars. Okay, could it be $4? No, because we've got this surcharge of $50 here. So let's do this. Let's put in 5 right there and see what our associated cost is. Okay, let's just use a calculator for that. So we've got 0.8, 80 cents. We're going to drive it 5 miles. And then we've got our flat fee of $50 that we have to pay yet. So we're going to be charged $54 to drive 5 miles. Okay? The ordered pair associated with the equation x equals 554, and it means that the charge for driving the car for 5 miles is $54. Does that one look right? That one to me seems like it's the obvious choice. How many miles was the car driven if the renter paid $188.4? All right, well, this is going to have to be algebra. So, first of all, let's see what we have. We have, don't do that to me, our generic miles, cost. So we go back up here and we see, what do we know? Well, we know cost. We're looking for miles. So we're going to put the 188.4 over here, and we're going to solve for x because that's what we need. We need the mileage. We've been given the cost. That's a it's just very small. Okay, so we're solving for x. We would subtract across my 50, right? So we have 0.8x is equal to, okay, this should be 138.4, right? And then I would divide through by the 0.8. Divide through by 0.8. Divide through by 0.8. Okay, so I'm going to just do the 188.4 minus 50. 50. So 138.4 divided by the 0.8. So I drove 173 miles. Okay. Let's check it. Good job. All right, and these last two are very similar. You know, maybe we should do them. They're always something. It's got 4 parts in it, so you never know. All right, so a printer charges $1.80 for binding plus 10 cents per page. So what is my fixed cost? What do I get charged even if I do 0 pages? Well, I get charged this $1.80. Okay, so that's my charge. $1.80 is fixed, meaning I pay that either way. My variable cost, well, what varies? Well, however many pages. So this 10 cents is the variable cost. Okay, I put 10 cents in as 0.1. So now we're going to write an equation using that information. So my variable costs, 10 cents per page. X is the number of pages. So I'm going to be charged 0.1 times however many pages I have. Then I'm always going to be adding in my fixed cost. So this is just like the other one. And then what will it cost to produce 28 pages? Well, the pages goes right here. So I'll use my calculator, 0.1 times 28 plus 1.8. It's going to cost me $4.60. If I were charged $9.80, how many pages did I get? The $9.80 goes over here, right? That's your cost. And I'm looking for the number of pages over here. So I have to do a little bit of algebra. But I know you can do that because we just did one like that. So you're going to put in the 980 over here. You're going to put in x here because that's what you're looking for, and you solve for x. And that'll give you the number of pages that would be binded, or bound, I suppose, for $9.80. And this last one, I think I'll leave you be on this because there's nothing new in here. Okay, we're going to write an equation. We've been given some points, right? Look at what we have. We have 3, 6946. We have 0, 3004. These are XY combinations, so I can find my slope, can't I? y2 minus y1 over x2 minus x1. Then I need that. Remember, all I need is my slope and my y-intercept. My y-intercept here has been given to me. It's where x is 0. So whatever your slope is, here's your y-intercept, plus 3004. Okay, and then you're going to start, it's going to start asking you for, either the x or the y values. So I think this section should be good. Anytime that you have trouble with a homework problem, you've got to go back and rewatch these. I'm getting people asking me questions that are very similar to the ones that I'm doing in here, and they say, I don't know how to do it. And I say, well, go back to the video. Going back to the video and rewatching things is totally normal. Another way of doing this would be to have this lecture open and up and running, and I get through problem number 1, and then I'm going to move on to problem number 2. You can always stop it, go into MyMathLab, and you try your number 1. Okay? Now if it doesn't work, then you rewind and watch it again up to that point, and then you move forward. That's another way of doing it. It's a little bit more efficient than watching the entire hour and then having to maybe a day or 2 later go back into your homework. You might not remember anything, so you might want to watch them side by side, with your homework, and do it that way. Another thing is if you do the Ask My Instructor button here, you really do need to ask me a question. Don't just click and this is all I see, because I don't know what it is that you're having trouble with. Or if you've put an answer in that's incorrect, it's really difficult for me to know what's going on. So, make sure that you show me your work. Put your work down on a piece of paper and scan it into the computer and email it to me and say, here's what I've done. Where did I go wrong? Email me with a Word document attached that you've got your work shown on there with a, you can type in stuff. Most Word documents have equation writer on them. Have you ever seen that? Let me show you something. Oop, that's not at all what I wanted. God, I hate when I do that. Okay. Okay, I'm going to go into Word, and I'm going to kind of drop this down so that you can see it. I can't drop that down, huh? No, I can't. You dirty dog. All right, you're in my way here. Yeah, this isn't going to work. But if you open up your Word and off to the right, you're going to see equation. That's where you've got in your equation writer. So it's got all the symbols and all the bells and whistles that you can use in a Word document, and you can show me that way. Another thing that you can do is go to the tutoring center and show them. Another thing you can do is make an appointment with me and show me. But just to send me your homework question doesn't do me any good. I don't know where you're struggling. I don't know what you've tried. I don't know what to tell you if I can't see what you've done so far. So I am going to require you to, when you ask a question, to ask a question, number 1. A lot of people don't do that. And number 2, you have to show me what you've tried so far. Okay? Because I haven't really let you go on any of these without some guidance. So, you might have to rewatch the videos more than once. You might have to reread the book more than once. You might have to do similar examples more than once. Online learning is extremely difficult. And if you're not willing to do all that, then online learning is not for you, especially in a math course. Okay? So I'm here to help, but I do have some requirements because I can't just do your homework for you. Okay? So that being said, I think I'm done with this section. There's one more to go, section 3.6. I think 3.5 was the inequalities, and I think I've skipped that. So I think we'll just do an introduction to functions in 3.6 and be done. So I will see you then. Take care.